Hello and welcome to the new video of the Numpy lecture series. In the previous video, we discussed about how to create an array using the array method, providing every data manually. In this video, we'll be discussing about the built-in generation functions used to create an array. So let's begin. So I have already imported the library into our code. So we have learned how to create an array using the array method, right? For example, arr1 equal to np dot array, and we provide the data inside a square bracket, for example 1, 2, 3, 5, 6, right? And we run the cell and see what is inside AR1, and we get a one-dimensional array with 6 data points, right? So what if I want to make an array with data that lie in a specific range? Maybe, for example, I want some numbers which lie between 1 to 10, for example. The Arange method can be used for this exact purpose. It is kind of similar to the range function that is available in Python. For example, let's create a new array, arr2 equal to np.arange, and let's specify the range. Maybe I want numbers between 0 and 1. And as you can see, inside the parameters list, we have a start index, a stop index, a step index, right? The start index corresponds to the first number in the array that we want. In this case, I'm going to provide 0. The stop index is going to be the last number, but in this case, the stop index is excluded. For example, if I want numbers in between 0 to 10, I will have to specify 11 as the end index because it excludes the end index and it gives me 0 to 10. Okay, this won't return me an array with 0 to 11. Fine. Let's run this cell and see what happens without specifying the step index. And let's see what is inside arr2. And we get a one-dimensional array with elements from 0 to 10. In this case, we haven't specified a step index. So what is actually a step index? A step index is the step taken to the next element. For example, if I add 1 as the third parameter, which is the step index, it adds 1 to the first element, then 1 again to the previous element, then 1 again to the next element, the previous element, and so on. For example, here the array starts from 0. So the next number will be 0 plus 1, which is 1, and then it adds 1 to the current number, which is 1, 1 plus 1 equal to 2, then it adds 1 to the current number, which is 2, 2 plus 1 equal to 3, and so on. So what happens when I do this? arr2 is equal to the same array which we got when we didn't specify the step index, which means by default the step index is always 1. I can specify the step index to a different number, maybe 2, and it gives 0 plus 2, 2, 2 plus 2, 4, 4 plus 2, 6, etc, etc. In this case, I'll get an array which is filled with only even numbers between 0 and 10. Awesome. I can even specify the step index to a floating point number. For example, if I specify 0.2, it will give me an array which is the step index is 0.2. As you might have already noticed, the array that we get from the Arange method is a one-dimensional array, right? We can always change the shape of this array using the Reshape method that we have learned in the previous lecture. And in order to do that, I just have to type arr2 dot specify the method reshape, and I'll have to specify the new shape. In this example, we have 12 elements, so I can reshape it into combinations of 4, 3, 6, and 2. For now, I'm going to reshape it into 4, 3, which will have 12 elements. 4 into 3 is always 12. I can reshape this into 6, 2, and we have like 6 rows and 2 columns with 12 elements, right? Okay, cool. This is a two-dimensional array now. Okay, cool. What if I want to reshape this into maybe like a 5 by 5 array with I can't do that in Reshape, but I can certainly do that using the Resize method. Let's see what the Resize method does. Inside Resize method, what we do is we'll have to create a new array. For example, like maybe arr3 equal to np dot resize, and specify the array that we are going to resize. as the parameter says, first is an array. So the first array is going to be this. We are going to resize this array arr2. So specify that array arr2, then specify the shape inside a tuple. So the new size I want is 5, 5, and let's see if we can do that by resize method. Yep. And let's see what inside arr3, and we get a 5 by 5 array. Notice the first 12 elements is same as that of the original array, right? And then the numbers get repeated. The next 12 elements are repeated, and again the last element is the first element in the loop. So this is how reshape is done. Let's learn about the second generation method, which is very much similar to the Arange method, which is known as the Linspace method. In Arange method, what we did was we specified the start index, stop index, and the step index, right? And in Linspace method, what we're going to do is we specify the start index, step index, and we specify a number which gives you that much number of evenly divided or evenly spaced numbers between the start index and the stop index, both numbers included. For example, let's create a new array arr4 equal to np dot linspace and provide the start index maybe like 0 and provide the stop index 10. And if I want like 10 equally spaced numbers between 0 and 10, I'm going to specify 10 as the third parameter, which is the number parameter, right? And let me run the cell and see what happens. Let me see what is inside arr4, and we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 equally spaced numbers between 0 and 10, both start index and end index included. What if we do not specify the third parameter, and let's see what happens. See, now there are like 50 elements from 0 to 10, equally spaced, evenly spaced. That is happening because inside the parameters, the third parameter is by default given as 50. The start index is compulsory, the stop index is compulsory. All the other parameters are by default given or assigned some particular value. Let's see what the fourth parameter does. Endpoint equal to true. By default, endpoint equal to true, which means that we need to include the end index inside it. What if we set it to false, like endpoint equal to false? Okay, let's see what happens. Let's run the cell, and as you can see, we do not have the endpoint as 10. Cool. Let's see what is the fifth index, which is the return step, which is equal to false by default. What return step does is it returns the step index of this particular method. See, this is actually, we have a step index, like in here it is, as you can see, it's 0.2, right? By default it doesn't return a step size, but in this case it is returning a step size if we specify it to true. So step equal to true, and let's see what happens. And when we run it, we get the array along with the step index, right? So that is all for today's video. We'll see you in the next video. Bye.